property of exponents. Continuing that process here. Review from last time is we had the zero property, which said that if there was an exponent of 0, any number raised to the 0 power is 1. And we have the negative integer property that said any number with a negative exponent is going to move across the fraction bar and the exponent is going to become positive. It doesn't matter if that negative exponent started in the numerator or it started in the denominator. Once it crosses the fraction bar, it becomes positive. So today we are going to begin with the multiplication property. And that, in layman's terms or in just talking terms, says if you have the same base, you are going to add the exponents. And the notation for this is a to the m times a to the n. You see these two bases are the same. We are going to add the exponents. Going to add those exponents. So as we go through some examples here, again, I think this is something you are familiar with. This is going to be 3 to the 3 plus 5, or 3 to the 8th power. 3 to the 8th power. I want to review here on your calculator. This is the exponent button right here, this caret. So I can plug in 3 to the 8th, hitting that caret button, and enter. And there is my calculation, 6561. 6561. Moving forward to a variable, if I have x to the 5th times x to the negative 2, the important information to start with is, hey, if it doesn't have an exponent, it's understood to be a 1. So you need to put that in there. And then this is x to the 5th plus 1 minus 2, or x to the 4th. If I have multiple variables, then I can only put together those that are alike. Meaning this is going to be x to the 3 plus 4. And then I'm going to have...
Teachers, pardon the interruption. Please dismiss afternoon JEL and ABC
y to the 5 plus 3.
to the main cafe to pick up their lunch before catching their
This
bus
is going to be x to the 7th.
for the ride to their afternoon.
And y to the 8th.
Thank you so much.
We would do the same thing if we had numerical bases that were different. Again, taking those bases that are the same of 3 and combining those to the 4 plus 2 and 2 to the 5 minus 2, which is going to give me 3 to the 6 times 2 cubed. We got to work that out. We got to know what 3 to the 6th is. That's 729. And we got to figure out what 2 cubed is, which is 8. And together, it gives us 5832. Again, one for you to try, x squared times y to the 4th times x to the 7th and the trick here is that while there is nothing for the y to the 4th to be added to, it still does and is included as part of the answer. Don't just leave it hanging there and say, well, there wasn't anything to combine it with. Yeah, I know, but it's still there. So the answer is x to the 9th, y to the 4th. Don't forget that, yes, these big dots mean multiply, but so do back-to-back parentheses. And as is the case in math, we start out here with a very simple concept of have these two have the same base, add their exponents, and then we just keep adding. We put two different exponents or two different variables in here. Now we got 3 in here. It's the same rule. Same rule. Don't change what's going on. It's just more crap to do in here. You are going to take the x's and 4 plus 5, and you're going to take the y's and 3 plus 4, and you're going to take the z's and 8 plus 7, and simplify those to x to the 9th, y to the 7th, z to the 15th. Okay, any questions there on the multiplication rule, multiplication property of exponents? Okay. The next thing we have is the power rule. So we're going from the multiplication rule that says we're going to add the exponents to the multiplication rule, the power rule that says multiply exponents. That says a to the m raised to the n power. The power rule, power to a power, is equal to multiplying the exponents. So, simply put, if I have 5 squared raised to the 4th power, this is going to be 5 to the 2 times 4, which is 5 to the 8th. And then you got to get your candy dandy calculator out. 5 to the 8th power. Whew, that's a big number. 390,625. If I have 4 cubed squared, that is 4 to the 3 times 2, or 4 to the 6th, which is 4,096. It's a lot easier when I have variables. This is just x to the 3 times 5 or x to the 15th. I don't have to worry about too much more. We got 2 starred problems here. Taking old knowledge and applying it to the new. 6 cubed raised to the 0 power. Says 6 to the 3 times 0, which is 6 to the 0. Anything times 0 is 0, which means the final answer here is 1. That's from last week. The second example says x to the 0 raised to the 5th power, which is x to the 0 times 5, or x to the 0. Again, anything raised to the 0 power is 1. Now the point here is it doesn't matter whether this 0 is on the inside or outside. I'm going to be multiplying those 2 exponents, and anything times 0 is 0. Any base raised to a power of 0 is equal to 1. Final answers must have positive exponents. So if I give you 2 squared raised to the negative 3 power, this is going to be 2 to the negative 2 times 3, or negative 6. You need to write this as 1 over 2 to the 6th. And 2 to the 6th is 64. So the final answer is 1 over 64. Similarly, if I have x to the 4th raised to the negative 3 power, this is going to be x to the negative 12th. I want this written as 1 over x to the positive 12th. Put your phone away. That's pretty important here. Final answers must have positive exponents. The next thing I need to talk about is again a reminder from Friday. Exponents only act on what is directly in front of them. And this is going to be particularly important to us now as we use this power rule with how it affects signs. And our examples here are all important examples. If I have negative x squared cubed, we need to understand that what is directly in front of this exponent is the parenthesis. So this is only going to act on the 2 inside the parenthesis. It is not going to come over here to this negative sign. That negative sign is going to stay, and this is going to be x to the 2 times 3, with a final answer of x is negative x to the 6th. Now I'm going to put the next one right beside it to show you the differences. On this example, the negative sign is inside. Of the parenthesis. Yes, the parenthesis right in front of this, so it's going to act on this exponent and it's going to act on this sign. And by that I mean a negative times a negative times a negative times a negative. There's 4 of those negatives. These two, when I multiply, make a positive. A negative times a negative here makes a positive, so my final answer is going to be a positive times a positive. Then this is going to be x to the 2 times 4, or x to the 8th. Does that make sense? The number of negative signs in there makes a difference. If I have a negative on the inside, there are going to be 5 negative signs. A negative, a negative, a negative, a negative, and a negative. And again, these two make a positive, these two make a positive, and there's 1 left over. A positive times a positive is a positive, times that negative, makes the whole thing negative again. And then I have x to the 2 times 5, which is x to the 10th. So the answer here is negative x to the 10th power. Questions there? All right, now we've done very well here. As you can see, we have one variable or one base number inside those parentheses, as we do in math many times over and over and over, is we start out with that and then we just build on top of that and we throw more and more numbers in there. It's not going to change the value of what we're doing. It's just going to be more crap to do. X squared y cubed raised to the 4th power. This is the power rule. Anything on the outside is going to be multiplied times the numbers on the inside, the exponents on the inside. So this is going to be x to the 8th, y to the 12th. It doesn't matter if those numbers are positive or negative, it's the same rule. Again, putting these two things side by side, multiplying those exponents, x to the 8th, y to the negative 12th, and reminding you, if you give me an answer with negative exponents, it's not going to get full credit. Any number is itself over 1. I need to write this using positive exponents. That's why we started with it before. So now you know this y to the negative 12th is going to come to the denominator and become positive. The x is going to stay in the numerator because its exponent is already positive. And again, this is just an example of what we do. We get you going, and then we just put more and more stuff inside the parenthesis. And it's just simple multiplication. This is going to be x to the 15th. Y to the 6th, z to the negative 6th. And again, anything is itself, any number is itself over 1. But I need to write this using positive exponents. X is all to the 15th is already positive. Y to the 6th is already positive. Z to the negative 6 is going to move across the fraction bar and become positive there. Now there is a variation of this. Variation of the power rule. But it's the same thing. So don't overthink it. It's not that hard. The rule is that if there is a power outside of the parenthesis, I multiply it times everything on the inside, all the exponent on the inside, right? It's the same thing here. X squared over y cubed raised to the 4th power. I am going to multiply the 2 and the 4 and the 3 and the 4. So this is going to be x to the 8th over y to the 12th. And again here, as before, we just put more crap inside those parentheses. So w squared, x to the 4th, y cubed, z squared, raised to the 3rd power. This 3 is going to be multiplied times each of those exponents. And it's going to give me w to the 6th, x to the 12th, y to the 9th, z to the 6th, because I can multiply. Okay? Does that cause anybody to pause there? Everybody good? You follow the train of thought that I'm going with, right? One more time, we're going to review what we've done previously. We know that 3x squared, we talked about this last time, that even though it may appear as though there's not an exponent here, it's the unwritten 1. And we want to put that in. Doesn't matter whether this is a positive base or a negative base. Again, what we need to understand is that exponent goes on the base, not on the negative sign in front of it. And again, lastly, if I have this happen more than once, I have to put in all of the ones. There's a 1 here, a 1 here, and a 1 here. Okay? And that becomes important as we expand, and instead of just having variables inside of these parentheses that we're raising the power to, we now have some numbers. So if I have 4x squared squared, I have to first realize this is 4x squared 4 to the first x squared squared. So then when I multiply, I get 4 squared x to the fourth, and this becomes 16 x to the fourth before I am done with it. Similarly, I don't want to be nonchalant and not put the 1 in. I have to be very tedious, very careful. If you do it, you will get it right. If you don't, you're going to mess it up. I've been doing it too long. 1 times 3 is 3. 1 times 3 is 3. Students will do it to the x, but they won't do it to the base. 3 cubed is 27, and x cubed stays as x cubed. Are we okay here? Everybody all right with this? Speak now or forever hold your peace. All right, incorporating some other things that we have encountered. This is a start example. This is a key one. It's got a lot of stuff going on in it. The first thing is I've got some unwritten ones that need to be written in. I see this -3. I'm going to proceed like I have. This is going to be 4 squared, x squared, y to the -6. 4 squared is 16. And that -6, I'm not allowed to have that in my final answer. So I am going to move that across the fraction bar and make it positive. The 16 has a 1 on it, so I don't move it. X squared is a positive 2, so I don't move that. And this becomes my final answer here. Sign, sign, everywhere is sign. Do this, don't do that, can't you read the sign? All right, incorporating this same stuff with signs, meaning that now I am going to have a number inside the parenthesis that's going to have maybe a negative sign with it. The 2 is going to be multiplied times each of these exponents. As long as I have an exponent in there, got to make sure I have one. And I'm going to count the signs. 2 signs is a negative times a negative, which makes a positive. Then I'm going to have 3 squared, x to the 4th, y to the 6th, and I've got to simplify this 3 squared to make 9, like so. And putting a contrary problem across from it, or a problem that's very different, but still involves the sign and lots of stuff on the inside. This negative sign is on the outside. I plug in my 1 and draw my arrows to my exponents. This exponent acts only on what's directly in front of it. It does not act on this negative sign. It's the one and only negative. It is not two. There are not two of them, like it is when it's inside. This is 4 squared, x to the 4th, y to the 6th. Again, this 2 acts only on the 4. It does not act on this negative sign. So we have 16, negative 16, x to the 4th, y to the 6th for our final answer. Does that make sense to you? We okay with that? All right, so we've given you one of these, and now we're going to do what we always do again. We just keep piling on. Just keep piling on. Now I have x squared y cubed raised to the 4th power times x squared y to the 4th raised to the negative 1 power. Now I got all kinds. I got two problems. This was an example before, and then this was an example. Now there's two of them in the same problem. Do things one at a time. Everything has an exponent. We're good there, so I can multiply. And I get x to the 8th y cubed. And over here, I'm going to get x to the negative 2, y to the negative 4. Back-to-back parentheses mean multiply. So this takes us back to the multiplication rule that we had at the start of the period today. When I have the same bases and multiplication between them, I am going to add their exponents. This is going to give me x to the 6th, and as I add the y's, I get y to the negative 1. If I did it right, but I didn't multiply correctly here, did I? That should be a 12, which means this is a y to the 8th. That is my final answer. So now I have 2x cubed y squared raised to the 3rd power times 4 x squared y to the 5th raised to the negative 1. Now, what we notice here is now different from up here is now I've got these coefficients in here. And I also notice that I have not written in the 1 for their exponents. So I'm going to do that. This makes it easier for me when I multiply. I end up with 2 cubed, x to the 9th, y to the 6th. Over here, I have 4 to the negative 1, x to the negative 2, y to the negative 5. And like before, I am going to combine the x's, and I get x to the 7th, and I combine the y's, I get y to the 1st. Don't forget about the 2 cubed, or the 4 to the negative 1. Any number is itself over 1, So that allows me to move this to the denominator. Does that make sense? X to the 7th and y to the 1st stay in the numerator because they have positive exponents. And 2 cubed is the same as 8. As I look at the fraction and I look to reduce the numerator and the denominator, I see they both are divisible by 4. So that leaves me a final answer of 2x to the 7th, y to the 1st. Is everybody okay with that? All right. Then addressing something they call, they do a little puzzle thing with you. They want you to tell them what exponent goes in here to get this answer. Two times 4 gives me 8, right? Everybody agree with that? But how to get to the denominator? It was negative. Correct. So negative 4 is the correct exponent. X squared y cubed is raised to what exponent to get 1 over x to the 6th, y to the 9th. Yeah, negative 3. And then this one's a little tougher, but you can figure it out. It's a puzzle. Huh? 4 and what?
Negative
4 and negative 3? Where do you want the 4 at? Huh?
in the parentheses.
Inside the parentheses? And you want what right here? Negative 3 or positive 3? 2 times 3 is 6, 4 times 3 is 12. These are in the numerator, right? They didn't move across the fraction bar the way they did here and here. The negative is what caused them to move. The numbers gave me the correct exponents. Okay? Make sense? All right.